All right, we should be live. Hello, everybody. Welcome, welcome. Just got out of a meeting. Sorry for the late live. Oh, I'm not going to cut the live short, but we'll just go a little bit longer into the morning. Hi, I think you're an incredible physicist. Well, I appreciate that. I don't know if that's true. Oh, we're peaking. Sorry, one sec. Yeah, I know. How's that? Is that better? Yeah, that should be fine. I don't know why, but like Oh, no, that's why. That would explain it. It like depends. We're peaking on YouTube too. I don't understand why. How about now? What is happening? What is Oh, test, test. Okay, so right about there. That's where we want to be. Okay, right about here, and then I can turn this back up all the way. I think to like here-ish. There. Okay, I think that we're okay now. Okay, good. Sorry for the peaking. I don't know why this happens sometimes. Um, there is no background noise. This is just my mic being funky, I guess. I really need like one of those things that's like a compressor, if you will. Anyway, I can reduce the volume just a smidge a bit more. That should probably be better. Yeah, I think we're better now. Right, okay. All right, let's answer some questions, shall we? Do rabbits exist? Yes. Do you still have Microsoft Automatic Gain? I don't think so. I never turned it off, but there is no noise around me. Are pigeons real or government experiments? They're real. Hey, label of a physicist, how much you get paid to lie? I don't get paid to lie. Bro, what's up with magnets? Yeah, so magnets are weird, but basically a magnet is just made of a bunch of tiny magnets. I mean, more like seriously, it's not so wrong. If you take like a permanent magnet, like an iron magnet, if you were to zoom in and somehow could do this, what you would find is that the electrons that make up the outer shells of these, am I still peaking? The electrons that make the outer shells of the iron atoms are just all spinning, but like in the same direction. How do I get paleodat? I don't know. I don't know what that means. Have you heard of monads? I've heard of them. I don't know what they are though. What is the most interesting thing that is understood the least in your view? Hmm, maybe like black holes, especially Hawking radiation. That's not really like I don't think that there's a good intuition for why they happen, why that happens at all. Um, do you enjoy doing math as much as you used to? Yeah. What's holding the atmosphere in place? Gravity. Why did they stop hiring physicists at Area 51? I don't know. I don't even know what Area 51 does. Do they still do anything? Why do the laws of physics break down at small scale, and how do they know? Well, it's not that they break down at small scales, it's that we know that quantum mechanics is dominant at small scales, right? That's it. Um, Dawn of the Atheist kick today. Every Tuesday and Wednesday I do science content. Um, I have a doubt. How much important is quantum optics and LIGO and gravitational waves? Explain in detail. I have no idea. That would be a question for like the physicists who actually work on that experiment. There is definitely, I mean, like we're talking about lasers here, and lasers are quantum objects or quantum systems. But I don't actually know how much, I mean, I'm sure that they do control for like quantum noise, for noise generated from like just vibrations at the quantum level, but I don't actually know if there's any actual quantum mechanics that are involved in running the calculations. Tell Ian to go live today. He robbed us of the stream yesterday. Look, I can't force Ian to do anything. Hi, I'm about to take PChem and quantum mechanics. What math should I brush up on before taking them? For quantum mechanics, brush up on your linear algebra and your differential equations. I've never taken PChem, so I don't know about that. What pure math would I have to learn to do a theoretical particle physics PhD from a physics MSc? You'd probably, I mean, you should have most of it. I mean, like you'll need like, I feel like most of it you'll pick up, but you'll need like Lie groups, you'll need representation theory, you'll need partial differential equations, which I'm sure you already have. What other pure math would you need? Maybe some differential geometry too, just so then you know what connections are. How does Hawking radiation really work? Why the mass loss? That's one of the, like we have the calculations that says it does work, but I don't know how well understood it actually is. Like if we actually have a good picture for what's actually going on. How close could he get to a black hole in its last hour of evaporating? Oh, it'd be really bad, like really bad. I haven't actually calculated how close you could get. Maybe I'll add that to my to-do list. Yeah, that's actually maybe a good video idea. Because I did a video a while ago on like how explosive it is, but I haven't talked about that in a while. Are you keeping track of the answers to the 4 questions that you ask MAGA? Could be interesting. No, but actually I should. That's a good idea. What's your most favorite aspects of being a physicist? I get to do physics, and physics is really cool. That's what. Okay, sir, can you suggest me on something? I have to choose between quantum information theory or astrophysics, which I take we have it this semester. I'm interested in quantum optics and all. It's just whichever one is more interesting to you. I care less about quantum information theory than like astrophysics, so I would do astrophysics if I were you. But that's like because I don't really care about like I honestly don't care a lot about quantum stuff, except insofar as we can learn about gravity. I care more about like gravity and the macroscopic. That's more interesting to me. Do we still not know what dark matter and dark energy is? Yeah, we still don't know what they are. What's your favorite paradox? I don't think I have one. What do you think of the idea that we are living in a white hole explaining inflation? So, in principle, we could be, but then there's no singularity in the past. Or rather, then we would expect that there's no singularity in the past. I don't know if anybody's actually taking this idea seriously. I'd have to look into it. Is the big rip going to happen? It doesn't seem like it, given current data. Are we in a black hole? Almost certainly not. Or at least we don't have any evidence that we are. Evidence that we are in a black hole would, let me center this, sorry. Evidence that we are in a black hole would look something like, we have a hypothesis. If we were in a black hole, we would expect XYZ quantitative observation to be made. Then we make such and such an observation, and that would provide evidence for the hypothesis. But we don't have that. How strong are 2 black holes that are orbiting each other? I don't know what you mean by strong, but they definitely orbit each other very quickly, especially as they get closer and closer together. How important are labs in experimental physics when learning physics coming from someone with a math background wanting to learn more advanced physics? Physics is an experimental science. Like fundamentally, it's an experimental science. There's a lot of like glory about the theoretical side, and I am a theorist, but it is an experimental science. If you can't connect it to at least, if it's not something that's informing something about the world around us, then you're not doing physics, you're doing math, right? What happens if two black holes meet? They merge. They merge and they become one black hole. Assuming a material of infinite length, how long of a lever would have to be to exceed c? Well, if you're going to invoke special relativity, which is what you're trying to do, then there is no such thing as a material of infinite strength. In fact, relativity precludes the possibility of such a thing. Can gravity carry space-time quantum information? Potentially, yeah. Nothing can go faster than the speed of light, but how much faster does light go being sucked into a black hole? Does it just depend how big the black hole is? So we can only really talk about speeds when they're local. And what that means is that it only makes sense to, like, in general relativity, where space-time is curved, it only makes sense to talk about speeds when the thing that you're measuring the speed of is right next to you. So if you are sitting next to a black hole and you're using your engines, so that, you're staying just outside the black hole, and then light comes in and enters the black hole, it will appear as if it is moving at the speed of light. Always. From every observer's perspective, light always appears to move at the speed of light. Well, okay, that's not quite true. But so nearby light will always appear like it's moving at the speed of light, I should say. Far away light might appear like it's moving faster or slower. But this is to say, it's not really a thing that you can talk about, but if somehow you could see light moving into a black hole from far away, it would definitely appear like it's speeding up. What's the slowest object in the universe? Probably the cosmic microwave background radiation, in the sense that it's kind of just like, that is the thing that we measure speeds relative to. So, how do you study an electron's wave function? Can we actually isolate and measure a single electron, or is it by observing averages? So you can measure a single electron. We have single electron detectors. But the way that you study what that electron was doing is you prepare a bunch of identical electrons in identical arrangements, and then you study averages of measuring these things over and over again. Doesn't light change speed in like water or some matter? So when I'm talking about the speed of light, we're talking about light in a vacuum. Once you have a medium involved, it's not really light anymore, or at least it's not light in the traditional sense. It's not a photon. It's not well described by the same mathematics that describes a photon. You might call it a polariton, you might call it a quasi-particle, whatever you might call it, but the point is it's not really a photon anymore. Where should I apply to grad school? I've focused on AMO recently. I have no idea. I have no idea what schools are good for AMO. How can energy at quantum level be discrete, and what happens between energy potentials? So it's not that energy has to be discrete at the quantum level, it's just that it can be discrete. So imagine that you have imagine that somehow you have a quantum spring, right? It's a spring that's like really, really small. Well, that spring can only oscillate at set frequencies. It just won't have a well-defined energy level if it's not at one of these frequencies, because of the way that the potential energy describes. There just is no potential energy between them. There's no way to describe such a thing. A photon is the measurement of energy in a quanta. No, a photon is a specific type of it's a specific oscillation, a specific disturbance in a freely traveling electromagnetic wave. Once you introduce a medium, it's no longer freely traveling. It's interacting. Which is more likely the correct interpretation of reality, string theory, or loop quantum gravity? I suspect none of them, or neither of them, rather. Aaron, with the $100, thank you so much. I appreciate you so much. That's so kind of you. Thank you, Aaron. Huge W for Aaron in the chat. Thank you. Wow. Okay. Yeah, okay. I should answer more questions. Why aren't stars more evenly distributed, given it all started with the Big Bang? So there's always going to be small fluctuations, and those small fluctuations lead to clumping because of gravity. Do you think humans will ever leave our solar system? Maybe, but not. I don't know if it'll be for a while. Is quantum entanglement faster than the speed of light? Entanglement is just like a static description. It's not a thing that travels. So no. You're thinking about like, can quantum entanglement transmit anything faster than the speed of light? And the answer, again, is no. Oh, by the way, that reminds me. So I haven't done this yet, and this is an idea I'm toying with, so, bear with me. So as you guys know, I'm currently self-employed. TikTok is my primary income, and then I do research. I spend about 3 to 4 hours every morning doing TikTok creation, and then I spend about 5 to 6 hours every afternoon doing research because it's the summer and jobs haven't opened back up yet. So what I'm considering doing for those who have like, go F yourself money, I'm considering making a Patreon level that's like $500 a month or something as like a genuine medieval patron. And anybody who's a part of that will get acknowledgements in any research papers that I was working on during that month. Like personal acknowledgements with like your name and everything. I know that that's so like, I don't know if anybody would be interested in that. I know that some people have like throw around money, like I don't understand that at all. But if anybody's interested in that, it's something I'm considering and toying with. So, get your name in a research paper, I guess. Right. Anyway, let me answer some more questions. Is that not unethical? Buy your way to credit? Well, no, they're not going to be authors. They'll just get acknowledgements. Actually, this is probably worth talking about because not a lot of people know this. So when we write papers, often if you're just employed at a university, you won't really have any acknowledgements. However, what will happen is sometimes you'll apply for a grant and they'll give you funding to work on a specific project, right? So like when I was a postdoc last year, or 2 years ago rather, I won a grant, I won an award for $1,400 to travel to Norway to collaborate with somebody. And then we worked on a paper there, and then we finished the paper, and then we finished. And so what happened was, because they gave me $1,400 to work on this project, I acknowledged them. I wrote down the grant number. I said, the authors graciously acknowledge the blah, 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 all the fancy words that you write in the acknowledgement section of the paper. That's fairly standard. And every scientist does this for the grants that they get. Now, I don't have any public grants, but there's no reason that people couldn't privately fund science, right? And, if people are interested in the work that I'm doing, if they want to support me, that's one way that they could do it. So it's something I'm considering. It's not set in stone, of course, but I think it's interesting. I think it's an interesting idea. Because it means that then there's a reason why I have to do research beyond just me being interested in it, right? Because at the moment, my income comes from science communication. Anyway, from old ECN with the $20, as a meteorologist, I'm jealous of how cool your research gets to be in comparison. It gets annoying sometimes that meteorology doesn't always have right and wrong answers. We can have all the right data, but still wrong. So not all physics research or math research is interesting. Some of it is, but not all of it. So like I have a few different projects that I just don't talk about a whole lot because they're interesting to me out of purely mathematical interest, but they're not like, there are projects that are a lot flashier, if you will. Yeah, so anyway, somebody asks, what are the research for? Are you allowed to talk about it? So the research that I did in Norway it's in a published paper. I mean, I don't make my name publicly available. That is, by the way, if I do this, what this would mean is that for those who are actually like, patrons, if you will, they would of course have my full name. They would of course have access to the papers before they're published and things like this. For accountability and all of that. In the same way that I would typically work with a public grant funding organization. Would time travel ever be possible in like a sci-fi way, like in the movie Looper? I haven't seen the movie Looper, but would time travel be possible? You can travel forward in time, but not backward. That's really the issue. Who are you, Mina? What would happen if a boson star and a quark star collided? Look, we don't know if either of those exist. So it's hard to say. A boson star, like, yeah, we have no way of saying what would happen if they collided. Although I suspect that they just form a black hole because that's what usually happens. Why can't we create an engine that is faster than the speed of light? Nothing can go faster than the speed of light if you have mass. And if you don't have mass, you can only go the speed of light. You can't go faster or slower. Is research slowed by money or time? It can be both. It depends on the person. So there will be like super highfalutin professors at like top tier universities where their research is essentially slowed by time. They need more postdocs, they need more time to work on their stuff because they have all the money in the world. Other people, like people at smaller universities, they might need a grad student or they might need a postdoc to help speed up their research, but they don't have enough money to do it. And then there's a third class of people who are kind of in the middle, who have the money that they need, have the time that they need. They just need to do the research. And like sometimes the thing is this, it's sometimes very hard to force research, especially for novel ideas, to like just force yourself to come up with a new idea. That's kind of hard. That's like the challenge of research, right? Can you talk about where the energy comes from in fission, specifically the changes in bonding energy and mass defect? So look, all that's happening, fission and fusion are actually fairly straightforward to understand at like even a classical level, right? So in fission, what you have is you have a big atom, and the atom, the nucleus of the atom it's very, very big, right? And so you have the strong nuclear force, the residual strong nuclear force. This is the thing mediated by pions, holding protons and neutrons together, protons and protons together, neutrons and neutrons together. It's a very strong force over very small scales. However, as the nucleus gets bigger and bigger, the electrostatic repulsion of the protons starts to overcome the strong nuclear force holding it together. Now, it's not so strong that it'll just spontaneously fly apart the instant it comes together. But what it does mean is if you split them even a little bit, now they'll fly apart. So when we talk about, so what's happening in fission is you have these big nuclei that all they need is they just need a little bit of a kickstart and then they'll fly apart because the force pushing the protons apart is stronger than the strong nuclear force holding them together. And so because they're pushed apart, you can get energy out. And this is all to say that energy has to come from somewhere. It comes from the mass of the nucleus. What level of math do you need for basic quantum physics? You need differential equations and you need linear algebra. Can you get the Leidenfrost effect on a star? I suspect not. I suspect the radiation pressure would be too high and it would just blast this stuff away. What are fractional excitons? I made a video about that a long time ago. I haven't thought about them in over a year, so I'd have to refresh my memory on that. Can you physically measure an electron's distance from its nucleus, or is it calculated from observing a secondary effect? So it's calculated, basically, from observing the energy levels, or the energy of the light that's emitted when you excite an electron and then let it come back down. Because there's a relationship between distance from the nucleus and energy and momentum and all of these things, and we can then establish the distance from the nucleus on average that an electron is using quantum mechanics. Why are doctors terrified of apples? That's a great question. Do you know what quantum foam is? Sure, it's kind of a metaphor for like what space-time looks like at the very, very smallest scale. If space-time is considered almost flat, are there not coordinates pretty large to measure speed? I don't understand what that question means. How is a weak force like gravity able to cause gravity waves in space-time? Well, look, any force, regardless of how weak, could cause waves, assuming that it has certain properties. It's just because gravity is weak, the gravitational waves are very, very weak. They're low magnitude. My mic's clipping. Again? Really? Okay. Thoughts on energy as the foundational aspect of the universe? It doesn't seem like it is. Energy is really hard to even define in an evolving universe. It might not even be well defined. I heard that unemployment or underemployment of physics graduates is relatively high. Is that right? And if so, why is that? And what jobs are for people at that level of physics? It's a good question. To be clear, so it is true that next to, I don't remember what the highest one was. So if you graduated from physics with an undergraduate degree in physics and then you didn't get any higher education, then it is definitely the case. Sorry, Mike is fuzzy. Okay, it's definitely the case that physics undergrad graduates have a pretty high degree of unemployment. That's true. That's a known statistic. I don't know why that's the case. There was a time maybe 10 or 15 years ago where like quantitative finance firms were looking for physicists because they're like physicists are so smart. But maybe that's just not as popular anymore. So you still have a lot of people applying for the position, but not a lot of people who are getting it, because now you have like people who are actually like experts in that field to start with. So yeah, I don't know what the actual root cause is, unfortunately. Let me double check. Yeah, I think we're okay. I don't know why the mic started peaking, but we should be good now. How hard was it for you to find a job after college? Well, after college, I went to grad school, and I applied to 7, and I got into 2. How does conformal cyclic cosmology explain the fine-tuning of the universe for life? I know Penrose has said that it does, but I don't understand how he gets to that conclusion. I'm not sure if it actually does solve the problem, to be honest. Can the Big Bang just be the creation of a black hole and our whole universe is in one black hole? Maybe, but we don't have any evidence that supports that, right? Can the Big Bang just be the Oh, I already answered that. Can you explain why people don't consider gravity to be a force, and if you do? Yeah, so gravity is a force insofar as any of the other forces are forces. Now, the reason why people... So there's like... have you seen that like pie chart meme, or not pie chart, I'm sorry, the normal chart meme? Let me actually pull this up. Because this will explain my point really well, and it's funny. So it's normal. It's like the bell curve meme, right? All right. Let's see. Is it this? Okay, it's this meme, right? You guys, surely you guys have seen this meme, right? So, let's do this meme really quick. So, with regards to gravity being a force, what you have is on the left, you have, you know, the low IQ nerd, or the low IQ losers who think that gravity is a force because Newton says it's a force, right? So you have these people who think that gravity is a force because Newton says it is. It's the force of gravity, blah, blah, blah. And then up here, you have the midwits who say, but general relativity says gravity is just the curvature of space-time. And if it's the curvature of space-time, it's not actually a force because nothing's pushing. Actually, and then down here, you have the gigachads who know that actually everything is a curvature. All of the quantum forces are curvatures. And hence, if electromagnetism, if the strong nuclear force, if the weak nuclear force, if those are forces, then so is the curvature of space-time. That is the true understanding of what gravity is. Anyway, so that's the bit. But yeah, so the reason why I would say that gravity is a force is because the way that we describe all of the forces mathematically is via curvature. It's the curvature of something. Now, gravity is the curvature of space-time. The strong nuclear force is the curvature of a non-abelian U3 principal or SU3 principal gauge bundle. It's just like it's a different mathematical object. So gravity is the curvature of the tangent space, which is a type of mathematical space, and the strong nuclear force is a curvature of another mathematical space. It just happens that's just is the way that it is. Right. Does redshift exist because photons lose energy as they travel, or something else entirely? Yeah, they lose energy as they travel. It's exactly that. Because they're stretched out, and the energy of a photon is related to its wavelength. How would exotic propulsion in UAPs work? I don't know. How would I know? It's supposed to be a mystery, right? Can we travel at the speed of light? No, you cannot. For forces with charges that can vary independently of inertia, a space-time formulation of those derivatives requires some auxiliary extension, roughly speaking. Oh, okay, yeah, that wasn't a question. Could gravity be emergent? It could be. We don't know. How good is the standard model? It's like so good. Especially if you just look at quantum electrodynamics, which is probably the one we understand the best. Quantum electrodynamics is so amazingly good, arguably, and it's actually not even a question. It is the most accurate scientific model we've ever constructed. Like the most accurate. Like it's accurate to like 10 digits, 10 decimal digits. What do you think happens in a black hole? I think that I kind of lean towards there just being like a hard compact core. How is Snell's law related to the definition of entropy? I don't see how it is. Does Newton's third law apply to energy? Newton's third law is about forces, not energy. So is a gravity wave time-space moving and compressing, or is time-space? Yeah, it's space-time going like this. It goes in, and then this part goes up, and then that part goes down, and this part goes out. It's like that kind of oscillation. Why protons are positive, electrons are negative? That's just how we decided what to call them. We could have made it opposite. It wouldn't have mattered. Why is there more matter than antimatter, or antimatter than matter? We don't know. But what we do know is that there is definitely an imbalance, because if there wasn't, we would see the boundary between the antimatter part of the universe and the matter part of the universe. And at that boundary, you would see like a wall of gamma radiation. Have you seen that JWST might have seen evidence for primordial black holes? I have, and it's really cool, and it's on my list of things I might make a video about it. From Cranky Old Cuber, thank you for the $20. Just joined, so apologies if this has been asked today. What's the best way to explain what energy is to non-physicists, particularly when they are treating energy as stuff? So I like to say that energy is just like another property of a thing, right? Energy is like it's a number that we use to describe stuff, just like how mass is a number that we use to describe stuff. Temperature is a number that we use to describe stuff. Speed is a number that we use to describe stuff. These are all just like speed isn't a thing itself. It's just a number. And it happens to be that that number is a number that tells us something about the way the stuff is moving. Energy is a number that tells us something about the way the stuff is moving and where the stuff is and how the stuff is arranged. And it happens to be that some of these numbers don't change under certain conditions. Momentum doesn't change. Momentum is a number and it doesn't change unless a force is applied. Energy is a number and it doesn't change unless a different kind of thing happens. Brian with the $5. Why do you suspect anti-intellectualism is on the rise? Is fighting this movement why you do what you do? Yes, it is why I do what I do, to at least in part. And why it's happening is a very good question. I don't know. I don't know. I mean, like, I have thoughts, but I don't know what the root cause is. How does movement at various speeds cause time dilation? Trying to understand it better. So the mathematically correct way of saying this is that everything travels through space-time at the speed of light. So we normalize time so that if you're not, well, let me stop and not use the word normalize. So if you're not moving, you're moving through time at the speed of light, meaning that you're moving at 1 second per second, obviously. But if you are moving, now you're moving through space at some rate. So that means that you're moving through time at a smaller rate because the total rate has to be the speed of light. That's one way to think about it. That explanation doesn't explain the symmetry. But to explain the symmetry, all you have to do is say, look, what your watch says is related to, how do I want to phrase this? Your watch ticks slower from somebody else's perspective the more distance you travel. Thoughts on JWST data challenging universe expansion theory? It's not. I don't think anybody's actually thinking that that's what it's doing. How does something with infinite mass occupy a finite space? Black holes don't have infinite mass. They have finite mass. You don't know maths, geez, you're just a pop physicist? It seems like I have to do this every time, but like, here's my notebook. Like this is one of my research notebooks. Like I don't know what you want from me. Like like what do you want? That's like the notebook that I like actively am using, and that I was writing in literally an hour ago. Is it worth it at 23 to start my degree in physics? If you want to do physics, sure. But, you know, the job market's not great. Um, have you submitted any paper? Actually, I just got notification that a paper that I and a few other people submitted like 2 months ago got accepted for publication in, where did it get accepted? JCAP? Did we submit it to JCAP? Yeah. Yeah, we submitted it to JCAP. So that's neat. Can never remember what JCAP stands. Journal of Cosmology and Astroparticle Physics. So yeah. Yes. So that would be like my 13th paper or something. Is there a way to reconcile general relativity with quantum mechanics in the next century? So I can't predict that. How could anyone predict that? Who knows? Is there a center of the universe? Almost certainly not, unless the universe has an edge, right? If the universe has an edge, then sure, but we don't think that the universe has an edge. Nobody really does. Can a particle the size of a photon travel at the same speed in a white hole? So if white holes exist, which they don't, if white holes exist, things can only travel out of them. Basically, all of the directions are outside rather than inside. In a black hole, all of the directions point towards the center. You're just a YouTuber, not a physicist. What do you call somebody who publishes physics papers? What? What? Can you share your papers? I mean, in principle, I could, but like considering I just got considering somebody just tried to dox me yesterday, like I'd rather not. Tell me why mass exists. So there's kind of two ways to answer this question, right? So on the one hand, the way that we think, what we think of as mass, like for electrons or for quarks or for the W and Z bosons, or for the Higgs boson, or not the Higgs boson, the way that we think of mass for those things is that they just arise from some sort of quantum interaction with the Higgs field, which is like fine. You can do that. You can. I drank some water, but I didn't actually acknowledge why Grimlock sent me water. Grimlock sent me $5. That's why I drank water. So thank you, Grimlock. What's your favorite color? My favorite color, it used to be blue, used to be black. I think it's green now. I actually like green quite a lot. Although I don't know if it looks good on me. Anyway, what was I getting to? Mass, right. So on the one hand, the mass of fundamental particles is just a form of energy that kind of looks like mass. And it's hard to describe if you don't look at the equations. There's something called like the Klein-Gordon equation if you're talking about the W and Z bosons. You have the Dirac equation if you're talking about the fermions. But essentially, you can write down these equations for a particle with mass, and you can write down the equations for a particle without mass. And once you include the interaction with the Higgs boson, those equations change. And it looks like they start to behave as if they have mass. So that's one sense where mass comes from. The other question of where mass comes from is like kind of from the relativistic point of view, and that we don't really know. I mean, in some sense, it's just like a feature, it's just like a type of energy, it's just the kind of energy that a thing has just for being stationary, but we don't really know like what it is that mass is doing, except that it curves spacetime. So it's a really hard question. In what topic did you get your PhD? So I did my PhD in, well, you might call it mathematical physics. I did work on conformal geometry, which with applications to the ADS-CFT correspondence. What's more likely in your opinion, the big crunch or the heat death? They seem to be, look, I don't think that the data, if you had asked me 2 years ago, I definitely would have said definitely the heat death. Now I'm less sure. I'm more agnostic about it. I don't know if the data is consistent with one or the other now, or which one it's more consistent with. Even if the universe had an end, we would never be able to observe it, right? If it had a spatial end, maybe we could if it was close enough. If it had a temporal end, well, we probably wouldn't live long enough. Tell me why charge exists. So there are kind of two ways to think about this again, but the way that we think of charge, let's say like electromagnetic charge, is that you have some principal gauge bundle. This is the U1 gauge bundle for electromagnetism, and essentially that bundle has a natural Lie algebra action that it can act on, representations of the of that bundle, or of that Lie group, Lie algebra. And so we say that a particle by definition is a thing that exists in a representation for all of the algebras that describe our universe. Now, if there is a U1, like the U1 algebra, U1 gauge algebra, that describes part of our universe, then particles that exist must be in a representation with respect to that algebra. And so we say that charge is just a description of the representation that the particle exists in. So we would say that something has zero charge if it's in the trivial representation. We would say that it has some non-zero charge if it's in the it's U1, so it only has one non-trivial representation. We'd say that it has non-zero charge if it's in the non-trivial representation. That's roughly the idea. If a quark star existed, would it have to be in a black hole? No, not necessarily. People have done computations of like stable quark stars, right? Some people even think that neutron stars are quark stars in their cores. How hard would you have to punch a rock to turn it into lava? I have no idea. It'd probably break first, though. I haven't really done physics since high school, but I'm really interested in getting into it. Advice? Well, so you could start by just reading some pop sci books. Like, you could read this. Brief History of Time's a really good book. It's a little bit outdated now, but it's still really good. You could also read some of the books by, like, Brian Greene. The old books by Michio Kaku are good. I wouldn't read anything recent by Michio Kaku. You could read anything by Sean Carroll. That's not the name of the book. It's just the set of all books written by Sean Carroll. They're all quite good. And so, yeah, you could read any of those, and that would get you, like, interested, get your appetite, see if it's something you really care about. And then there are some books that you could just start with textbooks. There's also a book called The Theoretical Minimum. I think it's by Lee Smolin, or it's by Leonard Susskind. That's also perhaps a place to start, but I haven't read that, so I can't really, I don't know how good of a choice that one is. But yeah, so those are some perhaps recommended reading to start. And then also watch PBS Spacetime, because Spacetime's really good. Okay, is there a way to slow down time? As in, so that, like, from your perspective, time is running normally, but everybody else is moving slowly? No, there's not really a way to do that. Not as far as we know. Sorry, my mic's peaking again, and I don't know why. Let's bump down the volume just a smidge on TikTok. Feynman lectures? I haven't gone over the Feynman lectures. I know they're really popular, but I haven't gone over them. Also, they weren't written by Feynman, by the way. I hope my audio's better on YouTube. Hope nothing changed. Any websites, YouTube channels for first-year engineering students? No, I don't know, man. Is pure energy real? No, energy is not a substance. It's not a thing in itself. It's a system. It's a description of systems. For grad school, can I do research in false vacuum decay and Higgs metastability and all that, or is it a waste of time? I mean, you can. Nobody's going to stop you. You just have to find an advisor who will take you on. Your take on creationist dismissal of Big Bang because of first and second law of thermodynamics? Rarely, if ever, do they understand what those laws mean. What do you think of renormalization group in QFT? It ties into ADS-CFT correspondence quite nicely. Look, the whole theory of the renormalization group by Wilson is, like, brilliant, and it's super, super important in QFT. And yeah, I'm aware that, like, you can kind of talk about how your system renormalizes depending on how you zoom in and out, which kind of scales with, like, distance from the boundary in ADS-CFT. It's like really, really important. I don't know what else you want me to say about it. Can a black hole go something boom and become a new star? So black holes, almost certainly black holes do evaporate, but they evaporate really slowly. Only once they get to a certain small size do they actually kind of go boom. And then no, they don't turn into a star. They just, like, explode in a bunch of gamma radiation, basically. Isn't a PhD a waste of time? If your sole goal is to make money, then you probably shouldn't do a PhD in physics. It's not, like, the best way to make money, right? Sorry. Will humans ever be able to make artificial wormholes? If yes, then what current theory procedure would they need to work on? So, as far as we know, one cannot make this because they require negative mass systems. Systems that have, like, negative mass. So matter, that instead of having positive mass, negative mass. And that means that if you push on them, they would go in the opposite direction. So almost certainly no, because they would kind of break everything. So yeah, I suspect not. Do you need series for linear and differential equations? So you don't need them for linear, like, if you mean linear algebra. You don't need series for linear algebra, no. But series solutions are very useful for differential equations. What are your thoughts on the spore drive in Discovery? It's cute, but, like, has no tie to reality. What is string theory? Why does string theory require so many dimensions? Yeah, so string theory requires a lot of dimensions because if it doesn't, then you get something called a conformal anomaly. Now, what this means basically is one of the reasons why string theory is so nice is because unlike other theories where unlike quantum field theory where there's like a lot of infinities and you get things and certain QFTs that you would like to write down have something called anomalies. Anomalies means that they don't really respect the symmetry. Let me back up. That was really complicated. So look, so there are certain symmetries that we know classically should hold, and so we want to impose them on the quantum system, right? And so generally we want our theories to be so-called anomaly free so that they respect the symmetries that we expect them to have. Otherwise, they're not the things that we wanted them to be. They're not the things that we expected them to be. Now, string theory is an example of a theory that has a certain kind of symmetry. Classically, it has a conformal symmetry. And the reason it has a conformal symmetry is because strings being two-dimensional, one in time, one of space, you can always rescale the space and the time coordinates, and it shouldn't change kind of the shape of the string, right? So classically, they should have this thing called a conformal symmetry. That's what rescaling means. Now, the trouble is once you do quantum string theory, you find that there's a conformal anomaly. If you try to do the rescaling, you get something that it doesn't look the same anymore. But the way that it doesn't look the same depends on how many dimensions there are. And it happens to be that in exactly 10 or 26 dimensions, depending on the kind of string theory you're doing, it happens to be precisely at 10 or 26 dimensions that the dimension-dependent anomaly becomes 0. And then you have an anomaly-free theory, which means that, it behaves exactly as you expect it to. Anyway, so that's why you need 10 or 26 dimensions in string theory. Do quants exist outside of space-time? You mean quanta. Do quanta exist outside of space, time-space? Why does anybody say time-space? It's space-time. As time doesn't really work for them, I'm making a cosmological model around it. It kind of connects relativity with quantum mechanics, but I'm lacking math skills. Okay, this is going to sound mean. It's not going to sound mean. It might sound deflationary, if you will. But if you don't have the math skills, like if you're not like formally trained in the mathematics related to physics, you're not going to be able to make a model, like a physical model. It's just not it's not going to happen. Unfortunately, that's the way that these things work these days. Physics is math, especially like model building, which is what you're suggesting. Model building is math. You have an idea and then you translate it to math. That's what model building is, right? Currently doing a math and physics double major undergrad. Any tips for Rex for grad schools? So do as well as you can on the physics GRE. That was probably the thing that stopped me from getting into all of the schools I wanted to for grad school. I had a 4.0 undergrad at a large institution. Double majored in math and physics. I had research. I had even a publication coming out. But I got an 880 on my physics GRE out of 9 with a max score of 990. And it's because I just couldn't be bothered to study. But that's somebody else who had identical stats as me, who got like a 950, got into every school that they wanted. So yeah, the physics GRE is important. At least it was when I was applying to grad school, which was 11 years ago. What's the difficulties with fusion energy? Yeah, so, ace the GRE math section. So if you're not acing the GRE, like the entirety of the GRE, especially the math section, then you might, like the GRE is not supposed to be hard for people who are like applying to physics grad school. Anyway, there was a question about what the difficulties with fusion energy are. So the main difficulty is containing the fusion reaction, right? Like when you're doing the fusion reaction, whether it's via inertial confinement fusion or whether it's via tokamak, the trouble is that you put a lot of energy into the system, it gets really hot, and then you compress it down to a really, really tiny size, and then fusion happens. And when the fusion happens, it releases energy. And in doing so, it gets even hotter, and the pressure gets even bigger. And somehow you need to contain that and keep it in a small area so the fusion can keep going. But currently, there are kind of two ways that we know how to do this. One is inertial confinement, where basically you shoot lasers at the thing so that stuff jets out, pushing it together. Basically, you shoot lasers at a pellet. The pellet that vaporizes the pellets. Plasma comes out of the pellet in one direction, compressing the stuff in the inside, which causes the fusion. And so you can get like little bursts of fusion. That's one way. That's what the there's a lab, I think it's somewhere that did that successfully. And then there's the kind of like the more practical version of fusion that might be useful for power generation in the near future, which is called magnetic confinement, where basically you have like a thin tube of plasma, and then you use magnets to squeeze them really, really tight. And that might work better because then the plasma doesn't have to touch anything, because the plasma is going to be millions of degrees, right? And if it touches anything, it would vaporize it. So you have to keep it separated from anything else. And so maybe you can use really, really strong magnets to keep it tight, but that's hard too. Plasma is just like a superheated gas where the electrons and the nuclei have been separated. From Grimlock with the $5, thank you. Is there a difference between model building and system building philosophy? I'm not familiar with system building philosophy. Model building is like, have idea, try to write down formulas that make that idea, like using existing frameworks, try to write down a formula that makes that idea like working, like a working model. And then we got another super chat from Orbowitz with the $5. Could nuclear power get humanity to the stars to colonize other planets, or is that a pipe dream? Yes, there was an idea. Yeah, so it is definitely true that once you have, if you can get to nuclear fusion, you'll probably have no issue getting, like, as long as you can make it reasonable size, you may very well be able to have fusion-powered spacecraft. That doesn't, National Ignition Facility, thank you, that's what it's called. But, you know, we don't have that yet. Do you live in the Czech Republic? I don't, not anymore. I did up until the beginning of June. By the way, charge exists to maintain manifold of broken symmetry of space. Well, that's not true. That's not what charge is. Charge is not maintaining manifold of broken symmetry of space. Charge is a description of the representation of a Lie group. What's your take on pilot wave theory? So, generally speaking, my take is that it seems more complicated than is necessary to explain what we have. So unless we find evidence, like alternative evidence supporting it, then we should not take it. We should not worry about it too much. Sorry, my phone's blowing up, and I don't know who's causing it. Oh, Yoshkin. So Yoshkin just sent $5 with the question, does mass increase with speed cause an increase, does mass increase with speed cause increase in gravitational effects? No, not unless it's contained. So what is true is that if you have two things that are moving together, moving towards each other very quickly, then the gravitational, you know, strength of that whole system will be bigger than if they move together very slowly. But if you just have one thing just moving, that thing won't, like, for example, you can't form a black hole by making something go really fast. It doesn't work. And the reason it doesn't work is because there's always a reference frame where something is moving arbitrarily fast. And if it were the case that if in some reference frame something was moving sufficiently close to the speed of light, then that it would form a black hole, then everything would be a black hole. But more specifically, velocity, speed, doesn't actually increase mass. It increases energy, right? Mass is a different thing, right? It's related, but a different thing. Mass is what we call rest mass. Anyway, thank you for the $5, Yoshkin. I appreciate you. Sorry, just double checking I didn't miss any other emails. Reconcile quantum mechanics and general relativity. Well, thank you for the $2.50 or €250 user, but I can't do that, or at least not on live. How do we know the speed of light is constant? If it's not, is time passing at different rates? Well, look, it doesn't have to be constant, but that's like the simplest explanation for the observations that we have, which is that whenever we measure it, it's always constant. And, you know, if it's not constant, if it is changing over time, well, then there's a lot of very confusing things then about the world. Like, why is it that if it's true that the speed of light is changing over time, say, and the speed of light being what it is governs a lot of the features of, you know, the universe, like it governs kind of like the colors that different gases emit. The speed of light shows up in like all sorts of kind of quantum mechanics, special relativity things, or sorry, quantum field theory things. So like quasars, like the emission spectra of quasars depend on the speed of light. Various, what are they called? Fine structures of the atom depend on the speed of light. So if it were the case that the speed of light was changing over time, speed of light and vacuum were changing over time, then it should be that when we look at distant galaxies, they should look like they're breaking the laws of physics somehow. And that doesn't happen. So it seems like they're not changing over time. From Deconstruction Zone, Justin, thank you for the $10. If someone created a container that can hold a single photon and placed a single photon in it, would it still travel at the speed of light forever? And if so, why? What's propelling it? Well, so, for example, you could imagine that you have like a pair of perfect mirrors inside a box, and you have a photon just going kind of oscillating back and forth in the box. In that case, yeah, it would travel at the speed of light forever. Light doesn't need anything to keep going. Light goes at the speed of light by default. If you want to make it change its rate, like go slower, you have to do something to it. You have to put it like, in glass or something like this. Could a theory of quantized gravity come from some manifold structure with a linearized metric? Well, so what you can do is you can do like an effective field theory for quantum gravity, where you just say, look, suppose that there's a flat manifold background, and that perturbations around that flat manifold are those are our quanta. We quantize the perturbations around the flat manifold, and then you can absolutely do that, and that's how you can get gravitons and all sorts of things. You can have an effective field theory where you just linearize around, say, Minkowski space, or linearize around de Sitter or anti-de Sitter space, or whatever you might want. That's definitely a thing that you can do. It's just not a theory of quantum gravity, right? It's not like a complete theory anyway. What happens when an immovable object collides with an unstoppable object? Well, not physics, certainly, is not what happens. Can we explain why quantum entangled particles seem to transmit information at speeds faster than light? Well, they don't. They don't transmit any information. That's a really important point to make, that there is no way to transmit information with entanglement. No way to transmit information faster than light with entanglement. Now, what does seem to be the case is it seems to be that there's a correlation between things that if they were classical objects, they shouldn't be able to communicate across that distance. But one of the implications, or one of the potential implications of this observation, is that maybe it's just the case that space is not something that is fundamental, and rather it's emergent. And it only emerges from things that appear classical, meaning that there is no entanglement. But once you have entangled things separated by a great distance, well, that's just because space doesn't make sense for them. Spatial separation is not a good description of that part of the quantum system. That's at least one possible explanation. Thoughts on the looks of Einstein's wife? I don't know what she looks like. This guy just read off ChatGPT, by the way, con artist. No, I didn't, but okay. If I did, then I'm really, really fat. I mean, I'll just put my hands here. What physically triggers wave function collapse beyond okay, couldn't read that. Beyond decoherence or an observer? We don't know. We don't know what causes wave function collapse. We don't even know if wave function collapse happens, right? We kind of assume it happens because you have a wave function that's well described by the Schrodinger equation, and then somehow, when you measure it, you only get one outcome, not like a superposition of outcomes. But another way that you can understand this is that you can understand it by saying, look, when we make a measurement, we enter a superposition, and so we only experience one of those possible outcomes because the rest of us, the other branches of us, experience the other possible outcomes. So that's one way to understand it. Can a 2D universe exist with the laws of physics as we currently know? If by 2D you mean like we're in 3D and you'd have a 2D universe, well, there isn't one. At least, like, if it was 2D, we would see it. If there was like a 2D universe, we would see it. But like, yeah, you can ask, like, what is a 2D universe? How does a 2D universe work? Like, how does it behave? And that's something that people have done. People study like lower dimensional versions of our universe to better understand what our universe is like. How would AI or general AI contribute to physics? Well, I don't know how general AI will, but currently I use ChatGPT for things like finding references, and because, one of the most annoying things when writing a paper, especially if you're doing it solo with somebody, like if you're writing a paper that you're not super deep in that topic, but like you have a novel idea, it's still a good paper. You might not know all of the relevant literature that's like required that you really need to be citing for like, to pay your respects to the community. And so ChatGPT is really good at like putting together kind of like the canonical literature and saying, okay, well, for this topic, these are the relevant references, and then you can go check and make sure that those are the relevant references. So yeah, definitely handy in that regard for like kind of doing the kind of mundane stuff. How do you feel about the Big Bang? It almost certainly happened. I know this probably isn't physics, but why is it that in a fire you have to go to the ground when carbon dioxide is heavier than air? Oh, I think it's the smoke that hurts you, right? And the smoke is rising. Is energy just like distance, something used to measure change, doesn't exist fundamentally? Distance might be more real than energy. Distance is like, I don't know, maybe. I mean, energy, you should think of energy as a property, not as the thing itself. How does lightning occur? It's actually more of an open question than you'd think. But the way that we think of lightning occurring is that you have some sort of buildup of electric charge by things rubbing up against each other, and then you have some sort of discharge that happens as a result of some nucleation event. Maybe it's a piece of antimatter streams in from space and knocks, causes something to happen, and then that triggers a breakdown and a cascade event that causes the lightning. What does it mean to solve Einstein field equations? So the Einstein field equations are general. They describe the relationship between a given type of spacetime and a given matter distribution. To find the solution is to say, if I know what the matter distribution is, what does the spacetime look like? That's hard. That's hard to do. Or let's say, if there's no matter, what could the spacetime look like? And the reason why it's hard is because the relationship between the matter energy and matter energy momentum distribution and the spacetime is that you take derivatives of the spacetime in like a horrible nonlinear way. Take derivatives of the spacetime metric, which is the thing that describes the shape of spacetime. You take derivatives of that to get the matter distribution. But if you only have matter distribution, you need to undo those derivatives, and that's hard. So solving Einstein's field equations means doing that. What exactly is the property of spin and what it affects it? So spin seems to be one of these intrinsic properties as a result of the way that spacetime is. So spacetime has something called, well, it has Poincare symmetry, has Lorentz symmetry, depending on which spacetime you're in, but at least special relativistically, it has both. And so one of these is that it has symmetry, is that spacetime has symmetry under rotations. And so what this means is that, like I was talking about earlier, we describe particles as being representations of the symmetries that describe our universe. So a representation is just like the way that the symmetry acts on the thing. So whatever symmetry our spacetime has, maybe it's rotationally symmetric, that means that everything that exists in it has to respect that symmetry. When you rotate it by a certain amount, it transforms in a canonical way. So when we say that something has spin, what this means is that it transforms in a very specific way. It exists in a very specific representation of the rotational part of the group. The rotational part of the symmetry, I should say. Now, this means that it contributes to angular momentum, by the way. This guy believes in climate change and got triple vaccinated. Yes, you say that as if that makes me dumb, but in fact, the fact that you think that that makes me dumb makes you dumb. Is it space that limits light speed, or is it light itself that has the limit? So it's space-time. Space-time has there are basically two options that you could have had for space-time. So you could have had a space-time with no speed limit, or you could have had a space-time with a speed limit. Our space-time, for whatever reason, has a speed limit. And so if it has a speed limit, then that means that everything that isn't limited by some other factor would travel at the speed limit. And so it's space-time that's doing the limiting. Quantum entanglement allows you to send information faster than light about the outcome in the other lab. No, it doesn't. You can't send information with quantum entanglement. Statistical mechanics or conformal field theory, which one to study, because time isn't enough for both. It depends on what you want to do. I hate stat mech, though, so I would do conformal field theory. Although I also hate conformal field theory, so make that what you will. Conformal field theory is just very confusing. To me, anyway. How is something an undefined expression when it is defined as undefined? That seems like a semantics issue. From $10 from Vader Sawyer. Thank you. Are photons quantized because electrons are quantized, e.g. an electron shell dropping an energy level causes the photon to have quantized properties? I appreciate your time, thank you. So there's two different things. So the energy of an individual photon is not quantized. An individual photon can have any energy you want within reason, just by changing the frequency, changing the wavelength. So that has nothing to do with why photons exist at all, right? Photons are quantized. They exist, or let me rephrase. The existence of photons is not a quantization of energy, but it's a quantization of the electromagnetic field. So what happens is if you do something, there's just a procedure called second quantization. It's called that for historical reasons. But basically, you can kind of promote the electromagnetic field to a quantum thing, impose uncertainty relations, impose kind of the typical features of quantum mechanics. And then what you find is like you can just do this and then maybe it doesn't describe a world, but then when you do that, when you impose these features, when you do the second quantization procedure, all that happens is that you get a theory that makes like wildly good predictions. And so we say, okay, well, then it must be the case that photons are, that the electromagnetic field really is quantized. This is to say, you could have actually had like quantized chunks of energy coming out from, or quantized chunks of the electromagnetic field coming out from electrons bouncing between shells without having photons at all. You could just have the electromagnetic field just like have that amount of energy that's just emitted. But the fact that there's a smallest amount of electromagnetic field is very weird. And that's what a photon is. What's the wavelength if the universe's mass energy became one photon? Well, it'd have to be the observable universe because we don't know what the mass energy is for the whole universe. But I don't know what the wavelength would be. It'd be very small. I'd have to compute it. Somebody asked a question about opinion on Phil Halper and Nieyash Ashforty. I've read one of Nieyash's papers. I like Phil's YouTube channel quite a lot. I think that together they do great work. I know that Alex O'Connor recently interviewed the both of them. I haven't watched it yet, but it's on my to-do list. When the electromagnetic field got unified, was it in the same way that electroweak was unified, or was it more uniform? It was a lot easier because when we unified the electromagnetic fields, we basically just said, look, they have basically the same equations. That was just an observation. I mean, Maxwell basically did this. He said the electric field is related to the magnetic field. They have basically the same equations. When one changes, the other changes. And now they're unified. Now they're two sides of the same coin, because when one changes, the other changes, right? The unification of the electromagnetic force and the weak nuclear force was a lot more complicated and a lot weirder, and involved like spontaneous symmetry breaking. It involved like a quantum field called the Higgs field. It was very, very weird. Can you explain Big Bang Theory? Because how can nothing create something? Well, the Big Bang Theory doesn't say anything about nothing creating something. So the Big Bang Theory, as understood by most physicists, and there's polling data that supports this, the Big Bang Theory just says, all it says is that 13.8 billion years ago, the observable universe, and potentially the whole universe, was very, very small. And for reasons that are not explained by the theory, so you have to come up with some alternative explanation for why this happened, the universe began to rapidly expand. Now, maybe it was doing something else before that, maybe it wasn't. The point is that the Big Bang Theory is just a theory about the history of the universe, not about the origins, not about where something came from. Have I ever watched Bobby Broccoli's science videos? I have not. I don't know who that is. Why does the thing do what it do and only sometimes but not ever? Good. That's a great question. 22.8 billion now, buddy? Nope, that's not true. Still 13.8. What's the closest theory about connection between relativity and quantum mechanics? String theory is the closest that we have right now. Could collapse bend spacetime like mass does? Can collapse happen when entropy flattens? I don't know what collapse you're referring to. You forgot they changed the timeline? Nope, they didn't. What coherent models provide evidence for an eternal universe? Well, I recently wrote a paper on it. Yeah, so, I mean, like, I recently wrote a paper that produces a coherent and consistent model that has an eternal universe. It's cyclic. From Chipotle Thunderbird with the $5, why is it when I put a fork in the microwave, my SpaghettiOs taste like pennies? I have no idea. Absolutely no idea. Can entanglement allow for fast and light communication? No. No, and it's pretty intuitive as to why. So suppose that you have two particles that are entangled. Well, you might say, well, why don't I just measure one, and then it'll collapse the wave function of the other one instantly. The trouble is, suppose that does happen. You collapse the wave function, and you want to basically, so you basically set it so that if I measure it, that's a 1. If I don't measure it, that's a 0. And then you have a time running it for both you and your friend. And then you can just make measurements and then send that information instantly. That's what you'd like to do. But when you make a measurement, the other person won't know that you've made a measurement until they make a measurement. And when they make a measurement, they won't know if the result they got was because you made a measurement or if it was just a result of random chance. And so in order to check if the result they got was because you made a measurement or not, they have to go back and ask you, hey, did you make a measurement? So they have to talk to you by some other subspeed channel. So it doesn't, there's nothing that can be communicated that way, right? How do electrons have a wavelength? Well, so the way that we describe electrons, the way that we describe all fundamental particles these days is in terms of waves. They are waves in an underlying field, or they're disturbances, if you will. And so those waves are going to have a wavelength. Did you ever have a girlfriend? I'm married. I've been married we got married at the end of 2018, so almost 7 years now. When do you see LLMs becoming most useful when it comes to physics research? I don't know. I hear that GPT-5 is coming out soon, so maybe then, maybe it'll finally be good at doing that. But I've tried. Like I tried to use ChatGPT for a recent paper as like a research assistant, just to like, run through like not simple calculations, but run through like, okay, if this happens, what are its implications? And it was really bad at it. Like it was not very good. What ChatGPT is currently good for, what I use it for, because I do have a subscription, is I use it as like a sounding board, basically, because I don't work well on my own. I mean, I can, but like it's good to have like something to like tell your ideas, and then just have it like, even if it's just reflecting back those ideas, it's good to hear them in another way. So that's kind of nice. On Alex O'Connor's recent podcast on the Big Bang, dark energy was characterized as repulsive gravity. Is this a good way of describing it? Yes. Yes, it is. Absolutely. Absolutely, definitely. Dark energy is absolutely just a good description as repulsive gravity. Yeah. How does van der Waals dispersion play into Euling's polarizability theory? I'm not familiar with that. I'm not familiar with Euling's polarizability theory, so I can't comment on it. How does the Everettian view deal with Wigner's friend? Well, so in the Everettian view, branching is not some objective thing. It's subjective. Branching is just like a way that you can describe the world that you occupy. And so in the Wigner's friend thought experiment, the person inside, they see the world as having branched. The person outside sees it as not having branched. But that's just because they're in two different bases. Or the way that they're measuring things uses two different bases. That's all. Do you think it's still possible to get a faculty today if I start from scratch? Maybe. Depends on how good you are and depends on how much time you have and whether you're willing to move. It's harder now than it was 10 years ago, definitely. Given that the stats of... Oh, this isn't a question. What about Penrose diagram? Do you thought about it? The way I think about relativity often is in terms of Penrose diagrams. So, is there any way I could access the paper? No. It's still under peer review, so no. Can you explain to me what quantum physics is? Quantum physics, at the simplest level, is just like what physics does at the smallest scales. Now, it happens to be that what physics does is very weird. Everything's waves. There are no particles. Things don't touch each other. They just kind of overlap. They change when you do stuff to them. It's very, very weird. But quantum physics is just about the physics of the very small or the very cold. Caden Davis with the $5 says, what are your thoughts on plasma cosmology and electric universe theory combined with anthropic principle and Fermi paradox theory? Plasma cosmology and electric universe are like nonsense. They're like there's not a single physicist alive that takes them seriously. The anthropic principle is super useful for understanding that some questions that we ask why about might not have good answers. And the Fermi paradox, well, that's not a theory, it's just a paradox. And it's not really a paradox. As far as I'm concerned, the Fermi paradox, which asks, if there is other life, why haven't we seen it? It's a pretty simple answer. The universe is big. That's it. Can you explain why time is different when gravity is different? It's not just time, it's also space is different. So yeah, like space and time both change when gravity is present, because gravity is the curvature of space-time. You get better answers from ChatGPT if you tell it to prefer subject matter experts, be concise, not to flatter you, and don't tell it what your pet theory is. Yeah. So often I will be like, and so I've also used ChatGPT as a way to like find the relevant literature and summarize things for me that I'm like need to familiarize myself with for whatever reason. So it'll be like, okay, explain as if talking to a grad student and citing your sources, I don't know, WKB approximation or something like this. So yeah, absolutely. ChatGPT is a useful tool. Just like all tools, it can be very useful when used by people who know what they're doing. It can be very dangerous when used by people who don't know what they're doing. So yeah, I think that's like, I mean, like, think about, like, I wouldn't tell a layperson to use a welding machine, even though a welding machine is wildly useful to somebody who's to somebody who's like a welder, right? I wouldn't tell a, yeah, so it's a tool. What is a false vacuum? So the false vacuum is an idea that so most of the fields in our universe, quantum fields in our universe, that describe electrons and quarks and leptons and the electromagnetic field and everything, their kind of default vacuum state is like 0. It's like at like a minimum, right? Or it's like empty, if you will. On the other hand, the Higgs field, its minimum is not, its vacuum state, its lowest energy state is not there. It's like somewhere else. So like so the Higgs field is at its lowest energy when the field is not at 0 value on average. It has a non-zero vacuum expectation value is the technical term. And so you can kind of think of this as like a minimum that the Higgs field is sitting in. It's sitting at the bottom of a hill or at the bottom of a valley, and it can roll around and be excited and stuff, but you know, its minimum is at the bottom of the valley. And classically, we say that, okay, well, that's the bottom. There's no other minimum somewhere else that it could transition to that's lower energy. But if you add quantum corrections, there's some evidence that suggests that there's actually some other way that the field can be configured that has even less energy than that. And so what you might call a false vacuum is that it's currently in its vacuum state, but it might not be the true vacuum. It could tunnel to a even lower vacuum state, and that would be bad. Right? At the bottom, it's in the Mexican hat potential, exactly. A quantum computer isn't just a faster classical computer, right? Right. Although you can model quantum computers as highly parallel classical computers. That's definitely true. So if you exponentially parallelize, you could think of it this way. A quantum computer with some number of bits is like a classical computer with 2 to that number of bits parallel cores. At least for a lot of quantum algorithms. Now, not for every quantum algorithm. There's still interference that happens that you can do, but that's one way to think about it. But no, it's not just a faster classical computer. There are things that I can do that a classical computer, there are genuinely new features that classical computers just don't have. Now you can like kind of model quantum computers because we can solve the quantum equations. And so like you can just tell a classical computer to just simulate what if a quantum computer was doing it, but that doesn't mean that they're the same thing. Why does the further you go from universe, the slower the time of that part of universe? I don't understand what the question means. What's the difference between a physicist and an astrophysicist? An astrophysicist is a type of physicist generally. Can it run Doom? I don't think anybody's run Doom on a quantum computer yet, no. So quantum computers only have exponential speedups on certain problems. They do have exponential speedups on some problems though. These are problems where we know that there's, you know, quantum supremacy, but that's not most problems, definitely. What's the consensus on gravitons in the standard model? Well, the standard model doesn't include gravitons, right? It just doesn't. But you can do effective field theories for gravitons, and that's a real thing. Yeah, Grover's algorithm. Yeah, there you go. I want to study cosmology. I've understood small bits of basics, physics, and math. What to study next? Well, pick up a textbook. Start learning. Pick up any textbook on general relativity. That will give you some cosmology stuff. Is it realistic to transition from a math undergrad into a mathematical physics postgrad? And if so, any advice? It's realistic, but you'll have definitely some catch up to do. Bye and good luck, Doc. We'll meet someday IRL. That sounds threatening. NASA just confirmed our electric field last year, and we're so sure to dismiss plasma cosmology and not take it seriously. What do you mean confirmed our electric field? The Earth has been known to have an electric field for a very, very long time. What are you talking about? But like, there's not just an electric field because there's gravity too. That's why the electric universe and plasma cosmology, that's why all that stuff is nonsense. Gravity's a real thing that we can test. What's the most interesting thing you've learned with direct real-world applicability in industry? I don't know. I don't care about industry. I really don't. Um, do you think a physics comp sci double major is worth it? It could be, yeah. You could be very, very efficient at like computational astrophysics, for example. Um, did scientists try to replicate the observer effect artificially or with other life forms? As far as I'm aware, and I could be wrong about this, but like, I think that most things where we talk about the observer effect having been done in a lab, it's never with somebody looking at it. It's like with a detector, like an instrument. It's what single sentence about physics would you send back in time 1,000 years to convey the deepest understanding to prior civilizations? Um, I would say 1,000 years. Um, Richard Feynman has a good quote on this. Let me see if I can find it. What did he say? He said, all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. So the claim is that, like, you know, that basically, if you analyze that sentence deeply enough, you'll come upon like nuclear energy, you'll come upon quantum mechanics, you'll come upon statistical mechanics. So there's just a lot built into that. Hasn't the Earth being electric something we have known since compasses, since the electric? Yeah, basically. What do you think is the most important thing to focus on in undergrad to prepare for grad school? There's kind of two ways. You could do kind of like the traditional way, which most students are going to be doing. Sorry, I have to pop my neck. Which is just get really good grades and do really, really well in the physics GRE, and then do some decent research if you can. Alternatively, if you're spectacular, go find a theoretical physicist and then write a paper with them or a few papers and publish it in a good journal. You like pure maths? Yeah, I do, but not all of it. Is it really possible to detect a single electron? Yeah. How can I get research experience in undergrad? Well, you just go up to a professor and you ask. That's what I did. I worked with two different professors as an undergrad. I did research for 2 years in like medium energy particle physics, and then I did research on like kind of theoretical or like kind of particle physics phenomenology. Sorry, my nose is so itchy. There we go. How does the signal reach the submarine in the last video you posted? Watch the video. It doesn't. We can't use neutrinos. At least we haven't yet. If the electricity produced involves electric field and magnetic field, how will eel produce it? What? I'm confused. Are you allowed to publish without a PhD? Anybody can publish, but you know, having a PhD means that you've been trained to do science. That's what getting a PhD is. You're being trained to do science. So like your publications will probably be better if you have a PhD. Why does light follow the speed of light? Why does it have a speed limit? Well, look, and I explained this earlier, but just briefly, either we could have been in a universe that has a maximum speed or that one that doesn't have a maximum speed. If we happen to be in a universe that has a maximum speed, and things without mass must travel at the maximum speed. Photons don't have mass. Who's your favorite theoretical physicist? It's got to be Einstein, right? It's got to be Einstein. Because we haven't measured the galaxy's current, it doesn't exist. Got it? What are you talking about? Why can't delayed choice be used for long distance signaling? Do you mean like FTL? Because in order to actually see that there's been a quantum thing that happens, you have to go back and compare, right? What is the universe expanding into? It's not. It's not expanding into anything. The universe rather is like the expansion is a local thing. So like each cubic meter of spacetime is getting bigger. Each cubic meter, or perhaps I should say smaller. Each cubic meter of spacetime is, if you wait long enough, becomes 2, 3, 4 cubic meters of spacetime. Modern physicist, who's your favorite? Penrose is still alive, so I'm going to pick Penrose. Do you think the term why things happen is misleading? I think it should be more how. I think why implies intention. Yeah, to a certain extent. What do you think about the physicists at UCL are doing on E-matter? Does this change anything with your... I don't know what E-matter is. I don't know what UCL is either. What would happen if the speed of light was not limited? Well, then there wouldn't be a maximum speed limit in the universe. Light would still have a speed. It just wouldn't have some... it just wouldn't be the maximum speed. How do you think the universe will end? I don't know. I just don't know. I think that there's not enough data to come to the conclusion anymore. Why is Earth objectively flat? It's not. Have you been to CERN? No. Unfortunately, I didn't have the chance to go to CERN. Did you see the new theory on de Sitter space and gravity being the start of the universe? I don't think that's new. Hawking was talking about that 40 years ago. Is it expanding or are we shrinking? We're not shrinking, and there is a way to tell this, namely that our galaxy isn't changing size, right? Atoms aren't changing size. It's only, the expansion is only happening where there's almost nothing. How do we fire a single electron at a time in an electron diffraction experiment? Well, you have an electron gun. You can control the intensity by changing the current with the current limiter. And then you just turn the intensity way down until you only get a blip every once in a while. What's your favorite live stream topic? I don't know. I don't know if I have a favorite. It depends on my mood. If you had to pick a favorite philosopher, who would it be? I don't know. Does Newton count? Is time fundamental, or does it emerge from entropy or quantum processes? We don't know. This is like an open question. I think the tide is kind of changing amongst foundations people. That like people who study the foundations of physics are kind of like slowly being more and more convinced at that like it's emergent, but I don't know. I don't think that we know yet. How do they shoot a single photon? Same way they shoot a single electron. You have a photon source, like a flashlight or a laser, then you just turn the intensity down, 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 until you only get one blip every once in a while. How is the charge stored and current passed through the capacitor? It's literally an empty vacuum. Please answer my question. Well, it's not a vacuum. At least for electrolytic capacitors, there's like a gap between them. But the point is that charge doesn't pass through the capacitor, right? What happens is that you have charge accumulation of one end of the capacitor. That induces an electric field. That electric field, that can cross empty space. It's an electric field. Electric fields exist everywhere. That electric field then causes a voltage or a potential difference. Actually, let me just put it this way. That electric field is at the other end of the capacitor, which then attracts charges from the other side. So don't think of it as the charge going across the gap. Think of the charge going here and then the charge being attracted from the other side. Best cosmological model given the current evidence? Don't say I don't know. Data has to support some theory more than others. Look, there's so many cosmological models. I mean, like, people are still using the lambda CDM model as kind of like the default one, but we're at a point where we don't know what dark energy is anymore. For a long time, it was thought to be a cosmological constant. We now have data that says that it's likely not. And if that's the case, if it's not a cosmological constant, we don't have a way to account for that. Now, you could just parameterize it and just say, look, instead of a cosmological constant, you just have some energy source that changes with time. And it just changes with time according to the data. But that's not really like a motivated model. And so, and I don't think that has a name either. What should I take? University physics or college physics going to biochemistry degree? Whichever one's required for your degree. I don't know what the difference is. What do you think of cosmology and physics? Because I'm going to have it next year. I love cosmology. Cosmology is awesome. Cosmology has become I haven't dumped black holes for cosmology, but I've definitely been seeing cosmology on the side. After CP violation, is there a possibility of CPT violation? What would be its implications? Yeah, so CPT violation, if it exists, would be a violation of Lorentz invariance, which would have huge implications. So yeah, I mean, I hope like it would be amazing if that was discovered at some point in the future. if quantum field theory is true, meaning that if like the way that we describe nature fundamentally is in terms of quantum field theory at a foundational level, then the CPT cannot be violated. But if quantum field theory is only an effective theory, then CPT might be violated, yeah. Ever read David Deutsch? I don't think I have. Does Unc respond? Yeah. Don't call me Unc, that makes me sad. Do any of the 19 free parameters of the standard model explain dark matter? I don't think so. Dark matter is not included in the standard model. Tim Ferpili with the $2. Thank you. Can you explain the Yang-Mills mass gap problem? Yeah. So the way that we talk about quantum field theory, the modern language is basically forces are described by Yang-Mills theories. So Yang-Mills is a type of theory. It's a geometric theory. It describes kind of curvatures of, they're called internal spaces. But anyway, so one of the features of Yang-Mills is that unless your principal gauge bundle is abelian, which all of them except the electromagnetic principal gauge bundle are not, so the weak nuclear force and quantum chromodynamics, these are non-abelian, so they have self-interactions. Basically, the particles, the force-carrying particles, can interact with themselves, not just with the things that have charge, because they carry charge themselves. So this is all to say that because they can interact with themselves, they can form bound states. So in principle, in quantum chromodynamics, the strong nuclear force, you can form just like a bound state, like a particle of gluons and gluons only. Now, the question is, what is the minimum mass of the so-called glue ball, the particle that's made just of gluons? Is there a minimum mass? Can you have like lower and lower energy particles, or lower and lower energy gluons that form a very, very, very low energy glue ball and hence very, very low mass? Or is there some lower limit? And if there is a lower limit, why is there a lower limit? And how do you determine what that lower limit is? That's the problem. And it's really hard to solve because QCD, quantum chromodynamics, is non-perturbative. It gets stronger at higher energies rather than weaker at higher energies. I don't know who's calling me. Sorry, it gets weaker at lower energies, stronger at higher energies. And so as you get to a bound state, which is going to be a low energy thing, the force gets stronger and stronger. So it's really hard to explain what's going on. Where do photons go from a flashlight if you point it through the sky? They go forever until they hit something. Does the wave function collapse only when observed, or is that an illusion of our knowledge? Or it could be that no wave function collapse happens at all. We don't know. These are the different interpretations of quantum mechanics, which is still an open problem. Will teleportation ever be physically possible? I suspect not. At least not in the way that preserves your conscious experience. Why do planets revolve in an elliptical manner instead of circular motion? Because of the centripetal force. So circular motion is a type of elliptical motion. And circular or elliptical motion is just what happens when at a certain distance, the planet is not moving at exactly the speed necessary to move in a circle. So let's say that, I don't know, like 400 miles above the surface of the Earth, something like this, 400 kilometers, sorry. A circular orbit has an orbital velocity of like 17,500 miles an hour, if I remember correctly. Actually, let me Google that just to be sure. Okay, so at 400 kilometers above the surface of the Earth, the orbital velocity is about 8 kilometers per second. Okay, so 8 kilometers per second, that's exactly the speed that you have to travel at to be in a circular orbit, approximately anyway. Now, if you instead put an object 400 kilometers above the surface of the Earth, but you made it go 9 kilometers per second, well, now it's going too fast, right? Now it's going too fast to be in a circular orbit. So whereas typically a circular orbit forms because gravity is pulling it down and it's matching the speed at exactly the rate it's being pulled down, so it travels in a perfect arc. Well, now it's going too fast. So the gravitational force isn't strong enough, so it doesn't pull it down enough. So it swings out a little bit and it'll come around. And so at the other end of the orbit, the other side of the planet, it'll be further away because gravity wasn't strong enough to pull it in tight. So what you'll end up with is because it was moving too fast when it was close to the planet, it ends up further away on the other side of the planet. Conversely, if it was moving too slow, then it will get closer to the planet as it swings around. So that's basically why there's elliptical orbits. It's because not every orbiting object is going to have exactly the right speed to form a circular orbit. Did I miss a super chat? No, I didn't. Okay, good. If you could dampen the Higgs field, would particles move faster? Well, you might be able to get like electrons to move at the speed of light if you somehow turned off the Higgs field, but that's not something that you can really do as far as we can tell. From a math perspective, infinite dimensions exist, whether or not they contain any physical entities. Is there a chance of other dimensions similar to ours of space and matter, or are we alone? So, look, so there's a question of whether or not mathematical objects exist in reality. Like you can describe, you know, whatever dimensional space you want. The question is does that exist? Like in the real world? And I lean towards no. I lean towards mathematical objects only exist in our minds. They don't exist in any other way. In which case, no, I would say as far as we have no reason to think that there are like other dimensions with other spacetimes and matter and stuff like that. Atheism is in all respects hateful. Francis Bacon, founder of modern scientific method. Okay, he was wrong. Is it possible that scientific phenomenons happen in front of people every day in front of people unrecognized? Yeah, sure. Like any electricity, any use of the cell phone like that, there's scientific processes happening there. Are laws of physics prescriptive or descriptive? I say that they're descriptive. Some would say that they're prescriptive. How do we have a gas pressure gradient next to a vacuum without a physical barrier? Separating the two, and if you say gravity, please provide the experiment proving this. Yeah, so if there's a gas pressure gradient, then there's no place where it's next to a vacuum. This guy's a flat earther, but we can engage with it just because, you know, flat earthers get to learn too. So if you have a gradient, what that means is that, you know, if you go up to 35,000 feet or something like this, your atmosphere might be half as dense, right? So you have a gradient, and like you can measure the gradient with a barometer in your phone. Pretty easy to check. Sorry, just double checking something. Right. So we all know that gradients exist. And so what happens is if you just continue that process, you just have a gradient. Well, then you'll never, and it's an exponential gradient, right? So it dies off exponentially. So near the surface, the pressure changes dramatically, but as you get further and further away from the surface, it changes more and more slowly. So you never actually get to like a true vacuum. Eventually what happens is that you get to the atmospheric pressure matches the ambient pressure of space. Space is not a true vacuum. It's just close to a true vacuum. It has like, you know, a few particles every cubic centimeter or something like this. So it just dies off very, very slowly. So there's never a place where there's a vacuum next to a pressure gradient or something. Now, what is the case is that we can derive a pressure gradient. If you assume that there is a gravitational force, then you can derive a pressure gradient. It just follows from Bernoulli's laws, right? Or Bernoulli's law. Is it Bernoulli or is it Pascal's law? I can never remember. Let me double check. Bernoulli law. Bernoulli's principle, I guess is what it's called. So Bernoulli's principle, is this the one that, yeah. So you can derive the exact exponential drop-off of the pressure gradient that we observe if you include gravity. And if you have some other explanation for why there's an exponential drop-off at exactly the rate we expect it to, that doesn't include gravity, by all means present it. But this is a really good confirmation that gravity is real. If gravity is real, we would expect an exponential drop-off. Then we go out and we find an exponential drop-off, and therefore that is evidence that gravity is real. Also, we can test gravity in other ways, so, you know. Anyway, it's not going to matter for them, but it will matter for the people who are listening who might talk to flat earthers at some point. Louis Pasteur, a little science takes you away from God, but more of it takes you to him. So maybe that used to be true back in the day, 100 years ago. But interestingly enough, if you take a poll of scientists, just general scientists in the United States, it's about 50-50, maybe 40-60, going one way or the other. For who's like for atheists or non-believers or theists or agnostics, whatever, like there's like a 50-50 divide roughly between people who don't really believe in God and people who do kind of believe in God, right? amongst just the general scientific population. And it depends on the field. Of course, biologists are less likely to believe in God. Chemists are more likely to believe in God. But roughly 50-50, maybe 40-60. However, if you then go, and by the way, that's smaller than the general population. The general population in the US is like a huge chunk. Like it's overwhelmingly people believe in God, right? So already scientists are less likely to believe in God just from the general scientific population. But if you then go to the National Academy of Sciences, which is, something that is like you have to be admitted to, it's like where the most elite scientists kind of hang out. There you find that it's like 70 to 80% or 75 to 85% of people 30 years ago were atheists, were like genuine atheists, not just agnostic, but atheist. And now, I mean, I haven't seen a recent polling data on this in the US. I've seen recent polling data in the UK, which is even more extreme. But like, yeah, so it seems like the better at science you get, the more acclaimed scientifically you get, the less likely you are to believe. So that's an interesting claim. Make of that what you will. But yeah, just like statistically, it is the case that people who are more acclaimed scientifically are less likely to believe. What do you think of the phrase "shut up and calculate"? It's a fun thing to tell grad students. How often should you get cancer screening? I don't know. Can you explain loop quantum gravity and string theory? I have videos on these that go into them in more detail, but they're basically both proposals. Well, loop quantum gravity is a proposal to kind of do normal quantum field theory to explain gravity. And it uses like holonomy, like the thing it quantizes, if I remember correctly, is holonomy, which is a complicated subject in itself. And then string theory is a proposed theory of everything that includes gravity. What is the consensus on Wolfram's work in physics information? Is he onto something? Nobody really in the physics community takes it so seriously. Are you related to Carl Sagan? No, I'm not. But I do appreciate the comparison. Does the math really prove that a black hole in one galaxy connects to a black hole in another? No. Can you explain dark energy in the Big Crunch to our best knowledge? So dark energy is just the name that we give for whatever is causing the accelerated expansion of our universe. So if you didn't have something, some energy density that was present everywhere, then the universe would be slowing down as it's expanding because gravity is pulling it back together. It could still expand forever, just at an ever slower rate, right? But the point is that unless you have something that provides kind of like that outward force of gravity, you're not going to have accelerated expansion, which is what we observe. Now, you could perhaps say that general relativity is wrong and that there's some additional theory that explains it, and you don't need some extra force of gravity, some extra outward pressure. And so people work on that. Those are just different models of gravity. And maybe dark energy is not real. Maybe we just need to change the theory of gravity. Fine. But all of these other theories of gravities, they have their own issues anyway. Right. But there's also this idea of a big crunch. Now, typically the big crunch was thought of to be ruled out because if the universe is accelerating and the universe is spatially flat, then it can't recollapse. But if it has a cosmological constant, if the dark energy is constant. However, if the universe is not spatially flat, if it curves back in on itself, and dark energy can change, which we now observe that it is, well, now the big crunch might be back on the table. It depends on how quickly the dark energy changes and things like this, but these are back on the table, yeah. Electrostatic is what we observe, not gravity. Can't prove gravity, only assume. No, we can do experiments that like rule out electrostatic causes for the attraction that we observe between two masses, definitely. But again, flat earthers won't listen. Did you see Alex O'Connor's video? I haven't seen that one yet. No, but it's on my to-watch list. Has there been any possible visual proof of white hole? No, there hasn't. And in fact, white holes, if they exist, should be super bright and very easy to see. And so the fact that we haven't seen them suggests that, they don't exist. So that's like it's not proof, but it is pretty strong evidence. But the cosmological constant isn't isotropic. Right. So that's another thing that, makes us question, is the universe going to continue its expansion forever? How does infinite crunch and expand work in a world with law of thermodynamics? So the second law of thermodynamics is a descriptive thing. It's a thing that like we always observe it, Like we observe it in like finite systems here on Earth and in space and stuff. But like there's not really a good derivation of it from some more fundamental principle that we expect to hold. This just seems to be kind of like a statistical thing that like in certain conditions, it is the case that the entropy of a system will tend towards increasing. It's just like a thing that we look out, and that seems to be what happens, so we call it a law. But depending on what your universe is like, it could be that it's just not satisfied at a global scale. And in fact, so for example, and I've cited this a lot, the paper is not publicly available. Well, it is publicly available, but not to you guys. So I was curious if there's a way to make this make sense, to make this work, to kind of get around the second law, if you will, with the cyclic universe. And you can do it. You can have a consistent model of or a consistent space-time model that includes quantum fields and that obeys general relativity. And what you find is that if it's arranged properly, if you have the right matter configuration, all of these things, then you can have a universe that expands for a time, and then it begins to contract. And when it begins to contract, you can just calculate what the entropy is of the universe, and you find that it's smaller than it was when it was bigger. So, like, it just does work. Do you have a theoretical degree in physics? No, I have a real one. I don't know where my PhD is, though. It's somewhere. It's somewhere in this house. I still haven't unpacked a whole lot. We'll find it. Let's see. Have you looked at any of the experiments the Chinese are doing with quantum entanglement over long distances? A while ago, yeah. As far as I know, there hasn't been any new news recently. Superposition is just a probability thing, right? Not merely material, or am I misunderstanding? It depends on your interpretation of quantum mechanics. The way I see it, I take superposition as like a real thing that actually happens. And it's not just like a epistemic thing. But maybe it's just purely an epistemic thing. How could you? Well, I know where it is. It's in like the document with like, or it's in like the folder with like my social security card, my birth certificate, and stuff like that, and like my important documents folder. I just don't know where I put that. It's somewhere in this room. So in your model, where does the supply of dark energy come from, or is it constant? So in my model, there is just a cosmological constant. It's a small positive cosmological constant. Is using AI for stock trading a good idea? I don't know. Doesn't sound like a good idea. How many articles have you written? More than a dozen? Most of them I co-authored with people, but like I have a few that I'm a single author on. I really like working with people more than working on my own, because you have like somebody to bounce ideas off of. But sometimes you have to work on something alone because, you know, why didn't you go into engineering, an actual useful field? Because I didn't want to. But if you don't think physics is useful, like, I guess say goodbye to your semiconductors that work in your phone, say goodbye to your transistors that are the size of quantum particle, that are like basically quantum particles, say goodbye to lasers, say goodbye to nuclear energy. Like, okay. What paper you wrote for your PhD? So it's a thesis, not a paper. My thesis ended up being 3 papers. I'm not going to tell you the name because that would dox me, but I wrote my dissertation on conformal geometry, and my thesis in particular has applications to ADS CFT. Where'd you do your undergrad? I'm not telling you that. Sorry. That's old physics. That's useful, nothing new is. Oh, I'm sorry. Do you think that superconductors are not useful? That's not old physics. That's stuff that people are actually actively working on. Do you think that graphene's not useful? Because that's new physics. That's stuff that people are actually working on. But okay. So what is the theory of the universe is inside of a black hole based on? It's not based on anything. There's no like theoretical model that it's based on. What's your favorite band? Right now I've been listening to a lot of Ghost, but I have to caveat this, because everybody's into Ghost. Ghost is huge. I love Ghost. The thing is, this is gonna be so cringe. I've been listening to Ghost since their second album. I saw them live in like 2018. 2017, maybe? I saw them live right after their second album came out. So, like, I'm not going to shame people for liking Ghost. Everybody should like Ghost. However, I liked them before it was cool, okay? Just saying. When two black holes collide to form a bigger black hole, what happens to the information they had swallowed before? Well, presumably it gets combined, right? Who the hell is Ghost? So Ghost is like they were on Fallon recently. Like their most recent album was like #1 on the charts for a while. Like they're a huge band. They're like kind of metal, sort of, kind of. A fan of any other metal bands? Yeah. So I'm into power metal. I found out about Ghost because they're power metal. And someone paid for a question. Oh, yeah. Thank you for the reminder. Jacob with the $5. Thank you. What's a quark made of? And what's that made of? How far does it go? And if nothing, how is something made of nothing? So look, either there's an infinite chain of stuff being made of smaller stuff. Maybe that's true. Or there's not. And at the bottom, there's just the fundamental stuff. Now, as far as we can tell, quarks are fundamental, which means that they're not made of anything. They are the fundamental thing that makes up everything else. They are the one of the underlying fields. And that's it. Unfortunately, it's not very satisfying. What's your favorite sci-fi prediction? The one that they got right? Flip phones, that comes from Star Trek, and I think that's cool. I enjoy Mariana Cross. Other Ghost song recommendations? Oh, you're in for a treat. So Cerise from their second album is spectacular. Probably my favorite song by Ghost. It's very eerie. It gives a very eerie friend. Very eerie vibe. Dance Macabre is a really good song. Really good song. I'm just gonna go look at their playlist. Why can't I sort by artist? Oh boy. Yes, I'm just looking at their discography right now. Yeah, so Cerise is really good. What did I just say? I'm just trying to think of I mean, Square Hammer is like classic. Dance Macabre is really good. Yeah, I don't know. Just go to YouTube, type in Ghost, you'll find some really good songs. Anyway, sorry. Sorry for getting distracted. All right, y'all. I actually think I'm gonna end the live here because I've been on for almost 2 hours and I do have to go eat lunch and make myself some coffee. So everybody, thank you guys for watching, and I will see you guys tomorrow for some more Q&A, some more Ask a Physicist. Until then, take care. Oh, and before I go, join the Discord. There's a link in the description of the YouTube video, and there's a link in the link tree in my bio that you have to copy and paste